Hello friends, in this video we are going to learn some questions about theory of computation which is also helpful in your GATE examination. Let's get started then. This is our question number 1. The word formal in formal language means the symbol you used have a well-defined meaning. They are unnecessary in reality. Only the form of the string of symbol is significant and D is none of the above. Let's see them. A symbol used have a well-defined meaning. This option reflects an essential characteristic of formal languages. In formal languages, symbols indeed have precise definitions or interpretations, which is crucial for their use in computational theory. Second, B. They are unnecessary in reality. This option doesn't accurately describe formal languages because formal languages are essential tool in computational theory and have practical applications in various fields, making them necessary in the real world context. Third option we have only the form of the string of symbol is significant. This option captures a fundamental aspect of formal languages in the theory of computation. In formal languages, the structure or arrangement of symbols hold significance often more than the specific meanings assigned to individual symbols. And D. None of the above. While option A and C capture essential aspects of the meaning of formal in the formal languages within the theory of computation, option D acknowledges that provided option may not fully encompasses the concept. So the correct answer is option C. Only the form of the string of symbol is significant. As in automata theory, a formal language is set of strings of symbols drawn for a finite alphabet. Fine. A formal language can be specified either by a set of rules, such as regular expression or a context-free grammar that generates the language, or by a formal machine that accepts, recognizes the language. Let's move to question number second. Question number second is any string of terminals that have generated by the following context-free grammar. We have a non-terminal and terminals. We have four options: has at least one B, should end in A, has no consecutive A's or B's, has at least two A's. We have to get the string of from these terminals. Let's see them. Has at least one B. To generate a string with at least one B, we need to ensure that either X or Y can produce B. Looking at the production rules from X and Y, we see that both can indeed generate B. So many string be generated by this CFG can contain at least one B. Second, we have should end in an A. Means it means the string should have a end with A. To ensure that the string ends in A, we need to focus on the production rule of Y because it's the only non-terminal that can directly lead to terminals. Y has production rule YB, but it doesn't have the rule directly leading to A. Hence, there is no guarantee that every string generated by this CFG will end in A. Let's go to third option. Has no consecutive A's or B's. This requirement means that no two adjacent terminal in the string should be same. Looking at the production rules, both X and Y can produce strings with consecutive A's or B's. For example, Y can produce AA or BB. Therefore, this context-free grammar can generate strings with consecutive A's or B's. And at last, we have fourth option has at least two A's. To ensure that the string has at least two A's, we need to ensure that both X and Y can produce S. Looking at the production rule, X can produce A and Y can also produce A. Hence, any string generated by this CFG can indeed contain at least two A's. So the correct answer is option D, has at least two A's. Option D is correct because both X and Y can produce A. Since there is no restriction on the number of A that can be generated, it's possible for a string to have at least two A's. The other options are incorrect based on the analysis provided above. Thank you.